one is not. This times this divided by the other one. 593 times 98.95 divided by 378. 155.2. It's going to be a pressure. The original pressure was in kilopascals, so this one is going to be in kilopascals. It didn't ask us to change it. On to the combined gas law. The combined gas law is the one that I've called Puvnert's. No, this is not it. Combined gas law is still the P1, V1, T1. It's just that nothing is going to remain constant. A gas at 138 kilopascals, that's pressure 1. 35 Celsius, that's temperature 1. We'll change that later. Occupies in a container with an initial volume, that must be volume 1. By changing the volume, the pressure of the gas increases. There's a pressure 2. As the temp is raised to, here's a temperature 2. What is the new volume? Volume 2. Here's my formula. P1 V1 over T1 equals P2 V2 over T2. Find the parts. 138. Volume 1, 3 liters. Divided by temperature 1, 273 plus 35, 308, equals pressure 2, 790. Volume 2, that's what we're ultimately after. And temperature 273 plus 120 is 393 Kelvin. There's a cross multiply, says that all of this stuff times all of this stuff will be equal. But in order just to cut to the chase, I'm going to start on the cross that does not include my unknown. So I'm going to multiply 138 times 3 times 393. Then I'm going to divide by the other two terms. I don't care if they're on the top or the bottom. Divide by 790. Divide by 308. When I press that enter button, I'll get 0.67. And that should be a new volume. Our original volume was in liters. 0.67 liters. (15 liters) of air, that's a volume 1. At a temperature, there's a temperature 1. There's a pressure 1. What will be the new pressure? We're looking for pressure 2. If the temp is raised to 100 Celsius, that's temperature 2. Volume expands to 30, and that would be a volume 2. P1 V1 over T1. P1, 1.75 atmospheres. V1, 15 liters. T1, negative 52 plus 273 is 221 Kelvin. Equals P2. Well, that's what we're trying to find. Times V2, 30 liters, over T2, 100 plus 273 to change it to Kelvin is 373 Kelvin. Once again, if my unknown is here, I'm going to start on the cross that goes this way and finish on the cross with my unknown. 1.75 times 15 times 373 divided by 221 divided by 30. 1.48. This is a pressure. The old pressure was in atmospheres. This must also be in atmospheres. We have a little less pressure. Now we're on to some Puvnert's. Solve the following problems. Got a lot of Puvnert problems, and a lot of them are already configured for exactly what I need. So on this one it says how many grams of nitrogen gas does the cylinder contain. I'm going to look for any formula of mine that I've already got broken into grams. There it is. Grams is equal to PUV molar mass over R times T. Lots of stuff, but as long as I know what they all mean, I should be able to go pick through this and find them. G equals PUV molar mass divided by R T. So start reading. I got a 0.3 liters, and remember that with these PUV-NERTs, it does need to be in liters. All these R values, or the R values that I have down here, were calculated using liters and not milliliters. This is already in liters. Figure out where the V goes. I'm just going to try to read through the problem and set it up rather than go and finding each part. I'm just going to read through and figure out what to do. With nitrogen gas to a final pressure of 2.5 atmospheres, 2.5 atmospheres times 0.3 liters. 29 Celsius, that's a temperature. I'm going to have to change that into 273 plus 29 will be a 302 Kelvin. What am I missing? An R value. And I have to pick the R value that has to do with atmospheres. That would be 0.0821. So a 0.0821 goes on the bottom. I'm also missing a molar mass. So I have to look to figure out what am I dealing with, the molar mass of nitrogen gas. Hope you remember that nitrogen gas is one of the horses need oats for clear brown eyes. So though it's though a mole of nitrogen weighs 14 grams, since I'm dealing with nitrogen gas, it's a 28 grams. So 28 grams is what should go there. Get the calculator, 2.5 times 0.3 times 28, divide by 0.0821, also divide by 302. 0.85 grams of nitrogen gas. Next one, what pressure in kilopascals will be exerted by 1.97 grams? Let me go find one. Is there one that deals with just pressure? Pressure equals NERT over V. P equals NERT over V. Except they didn't give us the N, they gave us grams of argon gas. So before we get to there, I'm going to have to probably go up and realize that grams, where are we at with this? That grams, that I'm going to have to figure out how many moles that is. Number of moles, N, is actually going to be grams divided by molar mass. So where it says N, I'm going to put 1.97 grams divided by the molar mass of argon gas. Argon is not one of the horses need oats, so simply 40. That now is my N. My R is going to be in kilopascals, so I find the R for kilopascals, which is 8.31. Temperature has to be in Kelvin. 273 plus 25 is 298 Kelvin. And finally, the volume is 3.75 liters. It is already in liters, so I don't need to change anything. 1.97 divided by 40, 0.04925. I'm not going to clear that. I'm just going to keep that in there so that I don't round and then get the wrong number. Times 8.31 times 298 divided by 3.75 and press the enter. 32.5. I'm looking for pressure in kilopascals. Kilopascals. That'll conclude all of the things on the seniors exam. After the seniors are gone, when we do a little bit more lab with some titrations of acids and bases, we'll know how to do these last two types.